Hello, everyone. We are excited to start a new problem we call a live comment system during live streaming. We'll start with the requirements. Live comment system. As usual, we'll start with the functional requirement. So the functional requirements will be user should be able to post comment, and then user should be able to see the live comments and comments before they join the broadcast. And we should support pagination as well because we may have a lot of comments. There will be non-functional requirements, and for the non-functional requirements, we'll start with low latency or more real-time comments updates. And then the second one will be the scalability. We're talking about 500 million DAU, and then 500 million DAU here. And for each user, they may see like, let's say 10 or 5. Let's say 5, 10 for easy calculation, live streams. That's the scalability we need to support, and then we will support high availability, for example, for nights. So for 4 nights, there will be only hours of downtime for the whole system for the year. And then we will talk about the eventual consistency, which means users should be see the comments in order and the same order for the comment eventually. Okay, so that's the requirements, and now let's talk about the resource estimation. We'll start with the QPS. So for QPS, we have 500 million DAU, and assume we have 10 live streaming watch every day. That will be like 5 billion requests per day, and if we divide it by 100,000, that'll give us so 5 million 50k QPS, and the peak could be 2x, 2 to 3x. That may comes with like 100k to 150k QPS query per second. Okay, so that's the QPS, and if one pod can handle 10k per pod, that gives us like 10 to 15 pods. Yeah, that's the assumption. And then we need to also support check about the data storage. And for data storage here, we mostly care about, for example, we have user, we have comment, we'll have the, oh, that's it, only user and comment. So for user, we have 500 million DAU, that's the user. And let's say for each user, we have 1 KB of data, so that gives us 100 GB. For comment, we may have 500 million DAU, and let's say for each user, they may update like, they may give like 10 comments per day. That give us 2, 5. Oh, for each comment, we need also maybe 1 KB. That's definitely the max, but let's assume that. So that'll give us like 1 TB of data per day. That's definitely like a lot. Also we want to talk about the, okay, so that's the data storage estimation. That means our system will be read and write heavy. So That's the conclusion of why we do the resource estimation. Now we start with the high-level design. So here we are talking about the API. We can use a HTTP REST API. So the first API will be post the comment. So we have the video ID, and then we have the comment. So you want to post some comment. And then we also have the get. We'll get the videos, some video ID, and we'll get a comment. But then we should have the, for example, cursor equals some comment ID, and then we may have a size equals 10, etc. This is for like pagination. That's the high-level API. That's for the user facing. We also internally will keep updating the live comment, but we didn't expose that API to the users. So let's start with the diagram. Now we have, for example, we will start with the post workflow. On the left side, we'll start with the post flow. We'll have the UI here. We will have a load balancer, and then the user will try to post to the load balancer. Then we may have the gateway, API gateway. So for API gateway, we'll do the common service check, for example, rate limiting, authentication, and logging, monitoring, etc. So that's the API gateway will call that. API gateway will also call the authentication service. And then API gateway will try to store the data to the, we'll call the common service, and then try to store the data in our database. So here we'll have our database. We'll have our Cassandra as the data store. We can talk more on that. So that's the post, and then we'll have another workflow here is the live update. Live update. So for the live update, similarly, actually the same UI or same app, but here just want to make sure this clear design. It will also have the load balance, maybe the same load balance, but definitely I will write it here again, and also the API gateway. So here we'll have the API gateway. Okay, so firstly, when the user log in, they will try to get the comment. They will try to get the comment from the API gateway, and they will try to query the comment service, and then from the Cassandra database, they'll get updates. That's like the second requirement, see live comment. But then we need to support the update. So that's the push from the server to the client side. Here we will try to push from the comment service to API gateway, and then API gateway will push that to the load balance to the user. So here we will use the, okay, for the update. Here we can talk about the server send event for the push. That's the high-level design, and here we will quickly mark the components or the talking point for the detailed design. For example, we will talk about here the Cassandra database. That's the first talking point. And secondly, we will talk about the serving sent event. That's the second talking point. And the third will be for the scale. We will introduce a Redis PubSub to scale. The PubSub will be here. When we talk about that, I can update the design here. Okay, so let's start with the first Cassandra database. So for our table, since it's comment table, we'll have the comment ID, which will be the primary key. We also have the live broadcast ID or live video ID, which will be the sharding key, and also the secondary index. And then we may have the user ID as the author ID. Will have the created at, and that will be the sort key for the comment. So that's the fields we have. Oh, we also have the content for sure for the comment. Like what will be the content of the comment. So that's the Cassandra table. Oh, actually, it's more like let's not use Cassandra table. Let's use DynamoDB. DynamoDB. I think DynamoDB will support the pagination in the design. So feel free to read more on how to query DynamoDB for the pagination. I think yes, let's use DynamoDB. We will still use the common ID at the primary key. We'll use the live video ID at the sharding key. Yes. So yeah, DynamoDB will make more sense here. However, downside for DynamoDB will be it's very expensive. Also, you may want to add a DNX here for the cache. So yeah, that's like the if we need to add a cache, and we will definitely add a cache. Okay, that's the table, and then we will talk about the second thing is server sent event. So we will not use WebSocket. The reason for that was for WebSocket is more bi-directional, and here the updates mostly just from the server side to the client, so it's not bi-directional. And the second part will be the server side event will like very lightweight and saving a lot of resource on the client side, both the client side and on the server side. The third one will be, okay, so now we have the post flow, we have the live update flow, and now we need to support the scaling we are talking about. So we cannot just keep querying the database here for the live update. Reason for that was even for DynamoDB cannot handle that load. We may have like millions, like we said, we have like 150K QPS, even more than that. We'll keep increasing the traffic or the user. So Redis PubSub will be in place. Now let's talk about that. So for Redis PubSub, we actually talked about this in the nearby friends design, but we will also talk about here. So for the PubSub, we will have the PubSub service here. And for the PubSub service, we'll have different channels. For example, we may have the channel for video 1, we will have the channel for video 2, we have different video, and video 3, etc. So for the update, we will have the comment service here. Comment update service will try to keep update. Like for example, for each video for each channel, right? So there will be so firstly we can have everyone update, everyone can talk to all the channels, and then we will have the consumer here to load data from like all the channels. That may work at first, but then we may support like millions of the channels, since we'll have millions of the live streams. That will not scale for each pod to listen to all the videos. That's where we need to introduce the sharding. And for the sharding logic, we will use consistent hashing for the sharding. That means we will have a layer here. We can call like service discovery, and then at the back of the service, we may have a Zonekeeper to have the map from like v1 map to pod 1, etc. for the mapping. And that will stored in the Zonekeeper, and then can access that via the service discovery. So every time when the comment wants to talk to the PubSub, it will query the system, the service discovery to get, okay, which pod it need to talk to. And similarly for consumer as well, it will also firstly talk to the service discovery, and then it know like, okay, which pod it need to talk to. And then that's only here. That's only for the PubSub. And now we need also to deal with the load balancer here, right? So we have the load balancer. We remember, and we will talk to the user via the load balancer about the live update. And then on the, so here will be the UI or the app or the client. So here for the load balancer, we will also support the sharding or the partitioning as well, and we will use like L7 load balancer. For example, we will have the video ID as part of the HTTP header, and then we know which consumer we will talk to, and then the consumer will know, okay, which client it will send the comment. So with this design, we will limit the pods, only focus on a subset of the channel or the pods, like which pod, which channels they will need to subscribe, and which channel they need to publish the comments to, and then send the message to the UI as well. That's the Redis PubSub. So the alternative design will be the, we can say dispatcher. Dispatcher, D-I-S-P-A-T-C-H, yes. So the dispatcher was, remember we actually talk about, talk about the chat service. Quite similar idea is, so now we have this comment writer, and then we have the updater, comment updater to update. Here is comment writer. So we have this comments writer, and then we will update the comments updater. The comments updater will try to update the load balancer and the client, etc. So for here, we will not use PubSub. We may use dispatcher. You actually like this. We just have the we'll have the dispatcher service here, and the dispatcher will know. So firstly, it will call the dispatcher, okay, and then comment writer will know which part it will update the comment. And then we will have the mapping here as well. For example, video 1 will map to pod 1. And then the comment updater will update the zone keeper, the load balancer into the UI here. And then we will still use L7, so the comment updater will know which client or which user it will update the comment. So that's it. That's the dispatcher. We can talk about both the pros and cons for the design. Thanks for enjoying the video.